Welcome back, math lovers. It's been a while. So this was the last Olympiad challenge which I had sent to you. So today we'll be discussing about this. Meanwhile, people who haven't actually solved this question or haven't tried it once, please do try it because this question is not a tough one. Even just with the help of Pythagoras theorem and triangle tools, anyone can solve this question, but it will be little time taking. I'm just here to help you with some math hacks which will make this problem a much easier one. The question says BAC is a right angle triangle is totally a 90-degree, and also it's an isosceles triangle. So giving us another edge, that means we know the angles altogether. The angle B and angle C both are 45-degree each. At the moment, I don't want to mark them because this question is about an angle chasing question. So, and there are certain lines being drawn here and there. So, I'll just give this information. I'll just remember it's important. Followed by D is a point on BC such that BD is 2 times CD. So, I'll keep point D to be here. BD length is 2 times CD. So, I'll just keep it as if this is A, this is 2A, this length will be 4A. So I'll generally take this like even multiples for division instead of writing A to A because some cases it will become like fractional when we proceed on. So that's always a good math act to keep with the even number distribution. And point E is the foot of the perpendicular on of B on the line AD. Okay. So what I'm going to do is the thought process works really well. So A to B, let's join this. And then they said it's a perpendicular from B which reaches to point E on the line AD. So this is perpendicular. Okay. So when there is second math act, when there is more than 190-degree or like there is more than one same angle in a triangle, then there's clear invitation to similar triangles. And one more thing is, it feels, the third math act is, it feels this BE line is like a broken line, meaning it's not completed. So generally Olympiads expect us to think whether such non-complete, incomplete lines can be completed enough, meaning they can extend it. All those extension ideas, I will just give a blue color. Extended to make some significance. Let's see what happens. Let's say I mean, extend this. The next part is to find angle CED. So just joining CED. Okay, people. So we need to find this angle. That's our question. Let's see what happens. Next is an isosceles triangle is there. So an isosceles triangle, the perpendicular from vertex of two equal sides will also act as median and all that. So that's a very interesting catch here. So we should be using that particular information. May not work for all the questions, but surely you should try. It's worth giving a try. That's the third to fourth math. I'm dropping a perpendicular from vertex A. Okay, we may call this point as M. So as I said, this AM will also act as median. Okay, to the triangle BAC. So total length of BC we have written it as 6A. So that means this length will be 3A and this MC length will also be 3A. So that means since DC is 2A, MD will be just 1A. Okay. And now people look at the beauty. Triangle ABD, AM is a perpendicular, BE is also a perpendicular, which means aren't these two altitudes of the same triangle ABD? Or triangle ABD, both AM and BE are perpendiculars, which means the intersection point of perpendiculars, we know it as orthocenter, isn't it? So this becomes orthocenter of H is orthocenter of triangle ABD. H is orthocenter of triangle ABD. Okay. Now notice that means if I draw a line from D point through H, that will also be an altitude, isn't it? So that will make 90 degree here. Then I understand line through DH. I need a marking for this. I'll name this as T. And this line DT will be perpendicular to AB because H is the orthocenter of triangle ABD. What we next notice is this is 90 degree, 90 degree. So these two lines are parallel, right? These two lines are now parallel. So DT line becomes parallel to AC line. But interestingly, we have some information about this part. When parallel line comes into picture, we can think of using, basic proportionality theorem. We all know that, I suppose. In a triangle, when a line is drawn parallel to another side, we try using basic proportionality. So in that case, if I wish to use basic proportionality in the triangle MAC, where DH line is being parallel to AC line, we can notice MD by DC should be in the same ratio as MH by HA. Okay, people? So MH by HA is going to be equal to A by 2A, which is nothing but 1:2. Okay? 1:2. So interestingly, so this is 1B, this is 2B, 1:2 ratio. This line passing through B, through this point H and E, which is a point here, let me call this as P. So can you figure out what this is acting as? Can you figure out what this is acting as? So what is line AM for this triangle BAC, people? Isn't it the median as well? The altitude as well as the median. On a median, you should notice this point H is like dividing this line AM in the ratio 2:1. But this 2:1, it's just like some deja vu feel, right? So because 2:1 is the way a centroid point will divide our median, which means we understand this H point is nothing but the centroid of triangle BAC. What we understand? We understand H is centroid of triangle BAC. That means the line BH passing on to reach till point P should act as median as well, because line passing through centroid has to be the median. So BP is median. If BP is median, then it will break AP and PC equally. So X by 2, X by 2. Okay, we are getting closer. So now we understand this triangle AEP as 90 degree, and let's say this angle, I'll mark it something like alpha. Do you understand that this AEP, I said this question will surely rely on similar triangles because they are angle chasing and there are a lot of same angles. Triangle AEP is being similar to triangle BAP because P and P, it is the same common angle, and angle at E, it has 90 degree, and angle at A also has 90 degree. So these two triangles are being similar. That's something to notice for us. And then you should also notice we mark the angles at the angle at this point will be 90 minus alpha because it's a very big sin. If you don't mark the third angle of a triangle, we know two angles, right? So because of that, this is 90 minus alpha. Then this angle will also be 90 minus alpha. Okay. Now considering next, we can write a ratio going forward for triangle being similar yet again. So let's just try to write a ratio for the same similarity. We'll try to exhaust what this similarity gives us as an info. I'll write AE by BA is equal to EP by AP, also equal to AP by BP, isn't it? I'm just writing corresponding side ratios. So I wish to extend this on to this side of the side length because like I'm more interested about this angle. CED is my question. So instead of AP, can I replace it as PC because AP and PC are equal? So this will give us EP by PC equal to PC by BP. So now notice clearly people, EP by PC, EP by PC with this in between angle and PC by same PC by BP. So with the same common angle, do you now recognize it just brings this small triangle EPC, just brings this small triangle EPC being similar to CPB, the entire triangle CPB. So now again, one more similarity we obtained. We'll just exhaust the angle chasing in that. So I'm going to mark this angle as beta, let's say. Okay, this angle will be beta. It's angle EPC. This angle is beta for me. Then it should be beta here also, no? CPB. CPB should also be beta. That's it. We are getting close. Now we already know this entire angle is 45 degrees. This entire angle is 45 degrees. Angle B is 45. I told you it's important. So 90 minus alpha plus beta is equal to 45. So which means 45 degrees is the value of alpha minus beta, people. Okay. Let's do some angle chasing to get to this angle. So now, again, we cannot commit a sin because we have marked two angles of triangle AEC. So which means this third angle over here should be 180 minus this left out, right? Right? Isn't it? Or else directly, can I just say this particular angle, which is our angle chasing, isn't it the exterior angle of triangle AEC? Our answer, angle CED, is exterior angle of triangle AEC, which means it's going to be equal to 90 minus alpha plus beta. This angle is 90 minus alpha, this angle is beta. It should be the addition of them. So since we already know what is alpha minus beta, which is 45, so this is 90 minus of alpha minus beta. So that is 90 minus 45, 45. That's it. So see, this is how Olympiad questions are made. Though they might be achievable through simpler techniques like just Pythagoras or like, angle chasing and all, but it will be more time consuming and mentally exhausting. But these techniques, these math acts which I have discussed in this question are going to be really helpful in much more even challenging questions which cannot be just like that achieved through simpler tools. Hope you like this question, people. So watch each and every step carefully to understand these math acts. Thank you.